All right, so today we're going to be looking at the 5 different types of reactions. So a chemical reaction is any time that you take one object plus another object, one substance plus another substance, and you add them together, and when they mix, they cause a reaction, and you get an entirely new substance. That's called a chemical change. The reaction is when the two actually change and become something completely different. So if you're looking on your handout, everything should go in exact order for the PowerPoint. So I'll make sure that everybody has the right things filled in their notes. So there's 5 at the top of your page. You'll see the box that has 5 different types of reactions. The first one is a combustion reaction. The combustion reaction is the burning of a hydrocarbon, which is a carbon and a hydrogen mixed together. The second type of a chemical reaction is a synthesis reaction. And synthesis always means to bring things together, to synthesize things. So this means that we're making one compound. Means that we're taking 2 things and making them be one. The third type of reaction is the opposite of synthesis. It's decomposition. And it means to break down one compound into 2 or more substances. So you take one thing and you break it down either into 2 things or maybe a lot more than 2 things. The fourth is single displacement. That means one thing is displaced or misplaced. And then the last one is the one that's, for me, the easiest to spot, and that's double displacement. So if you look in the next section, you'll see that there's a gray box right at the top of that section. And that gray box, what I want you to put in there is the type of reaction that we're going to be talking about. And for this one, we're talking about combustion. So write the word combustion. And then I want you to write in parentheses the word burning in that gray box. So for this one, combustion, it's anything that burns. If you're burning a leaf, a piece of paper, some firewood, whatever it might be, if you're burning hair, anything that you're burning is a combustion reaction. So from now on, when you guys are in lab or when you're at home or you're doing things and you see something burning, if you're looking at the stove and you see the blue light, that's a combustion reaction every single time. Combustion is a reaction in which oxygen combines with another compound called a hydrocarbon. And it forms carbon dioxide, which is CO2, and that is a formula that you need to know. Forms carbon dioxide and water. And H2O is water. If you don't know that, you definitely need to know that from here out. An example of that is burning of a wax candle. Wax candles are made of something called paraffin. And as it burns, it produces carbon dioxide gas and it produces water. And that's why you get a little bit of that water sitting at the top of the candle. The formula for that is right here. It's a big formula. C25H52 plus 38O2 yields, we read this little arrow as yields, 25 carbon dioxide plus 26 water. So 25 carbon dioxide, and what do you see? Carbon dioxide right here and water right here. If you see those 2 things, it's a combustion reaction, no matter what. The next one in that gray box, I want you to write the word synthesis. And in synthesis, 2 or more substances make one. So where it says only blank is made, that's only one substance. So you're taking, in your kitchen, you would be taking the flour and the sugar and the eggs and the milk, and you stir them together and you bake them, which is a chemical reaction, and what comes out is one single thing of a cookie. The general form for writing this is A plus B yields AB. So A plus B yields AB. And an example of this would be iron rusting. And that's 4Fe. Fe is iron. You do need to know that. Plus 3O2, which is 3 oxygens, yields Fe2O3. And if you notice, after the yield sign, Fe2O3 is all one unit. They can't be separated. There's no plus sign in between them. They're all together. In the next gray box, I want you to write the word decomposition. And only one reactant breaks down into 2 or more substances. I didn't leave enough space. I'm sorry, that line is kind of short, but it should be one reactant breaks down into 2 or more substances. And the general form for this is the exact opposite of what it was for synthesis. It's AB, so you're starting with the compound already together, and you're going to break it down, and it's going to be A plus B. So if synthesis is 2 people getting married, then decomposition is 2 people getting a divorce. Nice, right? An example of this is the electrolysis of water, and that's when you take the compound of H2O and you break it down and you get 2 hydrogen atoms and 2 oxygen atoms. In the next gray box, I want you to write single displacement. And this is a reaction in which a single element trades places with another element. And the general form for this one is A plus BC yields AC plus B. Notice which letter is the one that switched places over there. If you look very carefully, you'll see that in the reactant side, the side part to the left of the yield sign, on the left-hand side, you have A plus BC. After the yield sign, you have AC plus B. So C is the letter that moved. At the beginning, it's on the left-hand side of a plus sign. So over here, or excuse me, at the end, it's on the left-hand side of a plus sign. At the beginning, it starts out right here, and then after the reaction, it's not hanging out with B anymore. Now it's hanging out with C. So this is kind of like, over here, you've got the best friends, A and B perhaps are best friends. C is the girlfriend. And right now, B and C are dating. Well, after the reaction, B and C break up, and the girlfriend goes and dates A. And so now A and C are dating. Nice. And the example of that would be 2K plus MgCl2 yields Mg plus 2KCl. So K is potassium. You need to start getting familiar with these if you're not, especially the ones that have the weird symbols. K is potassium. So 2K plus MgCl2, that's magnesium chloride. After the reaction, however, you have an element over here by itself, and you have an element over here by itself, but it's not the same one. They've traded. They've swapped out. And this is kind of how it looks. What I want you to recognize is that the pluses always trade out for the pluses. Metals always replace other metals, and metals are your positively charged ions. If you remember what an ion is a charged particle. It can be a positive particle, it can be a negative particle. So positives are called cations, C-A-T-I-O-N-S, cations. And negatively charged particles, which are your nonmetals, are called anions, A-N-I-O-N-S, anions. And in the last gray box at the bottom, I want you to write double displacement. Oh, I'm sorry. I just realized that I didn't tell you to fill in those two blanks. It's metals replace other metals and non-metals replace other non-metals. Back in the single displacement category. In single replacement, it's always a metal for a metal or a non-metal for a non-metal. And in double displacement, it's the opposite. You actually swap out the metal for the non-metal. A double displacement is a reaction in which the cation, which we just said is the positively charged ion, of one compound switches places with the anion, which is the negatively charged particle, of the other compound. So you have the metal, which switches with the non-metal. The general form for this is compound plus compound yields compound plus compound. And an example of that is lead nitrate and potassium iodate. Notice, and this is not something you have to know right now, but notice down here at the bottom, NO3 is in parentheses, and over here it stays together. It actually travels that way. But notice that lead is right here, and after the reaction, lead's in the same place. But notice that iodine is after the plus sign, and after the reaction, iodine is before the plus sign. The NO3 switched, and so did the I. Okay, so let's look at this handy checklist and see what type of reaction is. So we're on the back side of your paper now. Does your reaction have oxygen as one of its reactants and carbon dioxide and water as its products? If so, then it is a combustion reaction. If so, it's a combustion reaction. Number 2, does your reaction have one compound on the product side? If yes, then it is a synthesis reaction. Does your reaction have one large compound on the reaction side falling apart to make several small ones on the right-hand side or on the product side? If yes, then it's a decomposition reaction. Does your reaction have one single element on both sides of the arrow? If so, it's a single replacement reaction. And lastly, does your reaction have two compounds on both sides of the arrow? If yes, then it is a double displacement reaction. So I want you guys to practice right now by yourselves, identifying the type of reaction. The first one up there is a double displacement reaction. So maybe that will help you guys get started a little bit. This first reaction is a double displacement, and there are 4 others. So I want you guys to figure out what the other 4 are. And if you're watching this at home or if you're in class with this, if you'll hit pause for about 5 minutes, that would be great. The second one, if you're going over these now, the second one is going to be a combustion reaction, and you can tell because the products are carbon dioxide and water. So anytime you have carbon dioxide and water as your reactant,